Hi, I'm following along with Paul McCorder's Raspberry Pi Pico W lessons. We're on number 4, where he shows the solution to his binary counter that he gave for homework in um, lesson 3. He this is he's starting at the absolute beginner level, and so it makes sense what he's doing. But his solution, I thought, it's great, but it actually, the person is actually doing the decimal to binary conversion. And all the microcontroller is doing is displaying what the person is already converted. Myself and a lot of others, I think, have been doing coding and maybe are here just to learn more about the Raspberry Pi Pico, but have been around coding for a while. Had thought that, well, let's use the power of the microcontroller to do those conversions for us instead of having to do it by hand and then just type it out. So there was a lot of in the teens of different ways I saw that people had done this, and I said, man, that's amazing that there's so many different ways of doing it. So there's basically 3 camps. I think I split it up into 3 camps. That one of them, and myself included, used bit math to pull out whether a bit was on or off on the thing, on the LEDs. And I did a couple videos on that, and a couple other people did bit math as well. The second camp, which was kind of, would have never gone that way, but it sure is valid, that they just did a division by powers of 2, and then subtracting if it off if they need to, and then continuing that loop through that to get whether the LED is lit or not. I can't remember the people that did that, but there were several people that were in that camp as well. The biggest camp, though, was the camp that lets the MicroPython convert the decimal number to a binary string. And that was interesting, and there was a lot of people went that route, and they're good way of doing it, but you had to overcome a little bit of hurdles when you were doing that. So I kind of demonstrate that a little bit here. So down here in the shell, we got this where, MicroPython will just, if you do binary of a digit of a decimal number, it's going to print out the binary of it. But we can see what a couple problems that we have here. First of all, it uses this OB to notate that this is going to be a binary number. And in small numbers, they only put out the number of digits that are needed to represent the number in binary. So that doesn't help us when we're trying to decide whether to light up 4 LEDs or not. I think Charlotte and BBF and a couple others might have come up with this idea. Well, if we just add the next digit, we're counting 0 to 15 to get 4 digits, that if we just add 16 to it, that's going to create a 1 on the 5th digit. So we know that it's going to have to display that. So that was a real interesting way of doing it, and smart way of doing it, and guaranteed that you'd have 4 of them. And so this is 2 plus 16, so that's your number. So if you just ignore these first 3, which you're going to have to already take care of the OB anyhow to get those out of our string. So now all you got is you got this extra 1, so you got that. So then if we do our split, our string split that we can do with it, and we take off the first 3 characters and throw them away, then you end up with just that. So that was the way several people did that, and to make sure that they got the extra zeros that they needed on the front end, so that they could loop through and by position and get those things. I know that when we were doing this on the Raspberry Pi, Paul had us do a similar counting in binary, and we were able to, instead of doing it this way, we were able to do a Z fill, which takes that whatever the number is and put the zeros in front of it, and that wasn't in MicroPython doesn't have a Z fill thing method, so we couldn't do it that way. But when I looked into the formatting of strings, they had this thing where you could add right shift. This is the right shift operator, and you can say you want to right shift it, and you want to tell you how many total places you have. So this is 4. We're going to right shift whatever is in our number, and we're going to have at least 4 places. And by putting a 0 in front, this means that we're going to fill whatever's to the left up to those numbers. We're not going to fill them with spaces. We're going to fill them with zeros. So I thought, wow, that's pretty interesting. So let's do it that way. So, we're hard coding our 4 in here. And but we have to get our binary number before we fill this, because we have to get our binary number like we did down here. Plus we have to get rid of the OB. So this is what this is doing. We're taking our binary of our range. We're doing counting here, and we're getting our range, and we're taking off the first 2 digits, and then we're right shifting them and then adding zeros if we don't need it. So that was a way of doing it. And then did a little bit more reading, and if you don't know how many numbers of bits that you're going to have before you start, or if you want to change it, you can actually make that a parameter as well. That instead of 4, we got our num bits as 4, we're putting that in there. So you could change this to 5 or 6 or whatever, rather than going into your code and do it. Or you could do it, in your program. You could actually change it if you wanted to. But that was a interesting way of doing it. I'm feeling pretty good about it. Then I was looking at a video from Lori from Lori's Robots, and she actually came up with a better way. So I decided to include that here as well. So instead of having to do the binary out here separately and take off the OB and everything, you can just represent your string as a binary number, and you can tell it how many bits you want, and that you want that you want to put zeros out in front of it. And so that was pretty cool that it was able to do that. And I also went ahead and tried out to make sure that, yeah, you could change your number with num bits as well and put that in there as well. That worked as well. So I figured I'd show that off for that working for her. So this is just going to loop through all 16, 0 to 15, and print it out. And you can see that's what it does. It just prints out all the numbers 0 to 15 and gives you those string numbers that you can go ahead and, like I say, you can use your positional to whether to light the LED that you have or something. So that was pretty good, and I thought that all the solutions were great, and I'm so happy to see so many people participating and putting up videos on that. Paul, I think you got a good group going here, and enjoy what you're doing. And even though you're doing beginner lessons, we're all learning together with the videos. Thanks, Paul, and thanks for everybody that posts videos. Have a great day, everybody.